Today we are looking at 7.4, properties of special parallelograms. Our special parallelograms are rhombuses, rectangles, and squares. Our essential question: what are the properties of rectangles, rhombuses, and squares? Our three special parallelograms. A rhombus is a parallelogram with congruent sides. So the sides of your rhombus have to be congruent, as well as opposite sides being parallel. A rectangle is a parallelogram with four right angles, so all our angles are right angles. And a square is actually a special rhombus and a special rectangle, as well as a special parallelogram, because all the sides are equal and the angles are 90 degrees. So one way we show our rules with our special parallelograms, all right, is this chart. So in a parallelogram, opposite sides are parallel. That's how we define it as a parallelogram. The rules we went over in the previous sections told us that a parallelogram, opposite sides are congruent, opposite angles are congruent. The diagonals form two congruent triangles. That's not actually something we went over, but that is true. And then the diagonals bisect each other. The next five, diagonals are congruent, diagonals are perpendicular, diagonal bisects two angles, all angles are right angles, and all sides are congruent. Those don't hold true in all parallelograms, but hold true in some of our special parallelograms. Because a rhombus, a rectangle, and a square are parallelograms, all the rules for parallelograms hold true in those. So we can check off those for all of our shapes. Okay, and then it's the stuff below that separate it. Right. So first one they give us is a rhombus. Right. Our definition of a rhombus says that all the sides are congruent. Oops, rhombus. So we know that all the sides are congruent, which is our last one. Okay. Because the sides are congruent, two other things are going to be true. The diagonals are going to be perpendicular. They're going to hit at 90 degrees. And the diagonal bisects the two angles. What that's saying on our rhombus, we come up here, is as the diagonal comes across this way, the angles at A are cut in half, the angle at A is cut in half, and the angle at C is cut in half. So the diagonal comes down this way, the angle at B is cut in half, and the angle at D is cut in half. Our rectangle we defined as having four right angles, so all the angles are right angles. Because of that, as I go from A to C and as I go from B to D, those lengths are going to be congruent. So our diagonals are congruent. Okay, so the top part is the same for all of them. The rhombus and rectangle are opposites on the other five. The square, because it's a special parallelogram and a special rhombus, is going to be all of them. We define it as having congruent sides and having four right angles. And that means that your diagonals are going to be congruent, they're going to meet at 90 degrees, and they're going to bisect the angles. So here, since the angle C, if you drew the diagonal, each angle would be 45 because the whole thing is 90. In a rectangle, when your diagonal comes down, that will not be the case. So the main way we use this is solving for parts in our shapes and classifying the shapes by what they show us. So the first thing we have here is classifying the shapes. So A, I look and see opposite angles are congruent. It's a parallelogram, but they're not the opposite angles aren't 90 degrees, so it's not a rectangle, and the sides are congruent, so this is a rhombus. In B, I have 90-degree angles, but I also have sides congruent, so this is a square. In C, my opposite sides are parallel, so I start at a parallelogram, but then the diagonals are congruent. So our diagonals are congruent in our rectangle, so then this is a rectangle. In D, our opposite sides are parallel, but the diagonals meet at 90 degrees based on this. So that gives me that this is a rhombus. Right. And in E, again I have sides parallel, but the angles here are bisected, which again gives me a rhombus. Example 3 says I have a rhombus, right? And then gives me my picture. It gives me some other information in there as well, but that's drawn on the picture. So first thing they ask me is for AED. AED. And one of our rules for a rhombus is that diagonals are perpendicular, so that's 90 degrees. I don't even have to do any work there. All right, if I know the rule, I know my answer. Then they ask me for DB. All right, so since this is 8, that is 8, and DB is 16. There, I didn't even need a rhombus. My parallelogram would work for that. And then AC, which is where I start using the rhombus, right, gives me that this is also 16. Because that, oh wait, that's not right. That would be a rectangle. How am I doing this? So they give me that is 8. Do they give me enough information? Oh, all right. So this, we haven't dealt with this in a while. This would be Pythagorean theorem. This is 90. This is 8. So I can solve this side. 8. Actually, I'm not sure we've gone over this yet in class. So that would be my setup. They don't show me this is 10. I had to fill that information in. All right, I fixed this on a previous worksheet, but not on this one. So I solve this. I think that comes up somewhere else in this worksheet. If we deal with Pythagorean theorem, we'll go over that in more in depth in class, because it's something you're probably familiar with, but technically we haven't learned it yet this year. All right, then B tells me it's a rectangle. They also tell me QS is 10. Which is not drawn on the picture because it's the whole line. And to solve it, I also need to know another part. So I'm going to say that QT is 6. And that'll be given information as well. So then they asked us for QPR. QPR. Now this is not 90 degrees because it's not a rhombus. I know this angle is 34. Right? I know this whole thing is 90, so I could solve this angle. But I also have alternate interior angles. So this is 34, QRP is 34. Right? And because these sides are equal, it's isosceles, this angle over here is also 34. So I know these two angles here are equal and are both 34. So if I do 180 minus 34 times 2, which is 68, I get that this angle is 112. RP, they tell me QS is 10, and then our rectangle, our sides have to be, or diagonals have to be congruent. So then RT is 10 and RP is 5. And then they ask for RS. Opposite angles are congruent, or opposite sides are congruent, so this would be 6. If I didn't have the 6 here, we could use trig to solve it. That is not something we have gotten to yet, which is part of the reason I gave you the 6 on that side there. And then our last problem, they tell me that this shape is a square. They give me the LK is 1. And I want to add information in here, but we'll add that in later when we get to needing it. So first thing they ask me for is LMK. This is this angle here. I know the whole angle at M, LMN, is 90 because it's a square. And I know the diagonals bisect because it's a square. So angle LMK is 45. They also asked me for KN. Right? And all my diagonals are equal. And since this is 1, each part would be 1. So KN is also 1. And then they asked me for LM. Right? Now, since this is 90, we could use... or actually, what did they ask me? They asked me for LP. So since this is 90, we could use Pythagorean theorem again. What I want to say is I'm going to say LM is 1.41, which is and then since all my sides are equal, LP would be 1.41. And that, so again, we're looking here at special rules of our parallelogram.